Hi, I hope the background noise isn't too much. I live with a lot of people, so it's a bit difficult to record, but I have a quiet room, so I hope it's not too much. I'm not able to integrate my camera into this corner. The application doesn't allow me. I tried it; it gives me an error constantly. So introductions first. Hi, I'm Nayan Chaudhari, and this is my final project as submission for Bioinformatics programming BINF 6200. And it's a project called Taxonomy Explorer, a web application that allows users to explore taxonomy data, similar to how NCBI's taxonomy browser works. This app was built using fast API front backend dash frontend, and the database is powered by SQLite with SQL model. So how does the application work? It's a tool it's a tool that lets you search for taxonomic names with using flexible keyboard based interface. And I'll get this set up while I'm explaining that. It's a tool that lets you search up, any taxonomy details that you want, taxonomy data that you want, including its scientific rank, the parent taxon, the child taxa, and uh, well, you can navigate through the taxonomy by clicking links. For example, moving from a species to its genus or vice versa. Everything is built to be interactive, responsive, and reproducible by Python. So I'll get this set up. That's the backend working, and so we activate the virtual environment and then go into the place where all everything's there, and then we start running the front end so that the web page is visible. It shouldn't take. Okay, yeah, so it's working. Before that, I'll just explain you the well, how does the application architecture work, and how do we basically go about doing what we do in this. So I'll just open up the code and I'll give you a brief description. So before that, as you can see here, I don't know how visible this is, but yeah, make it bigger. App data front end. So app as the backend, front end, and the data that's populated. The README file has everything that you need to know how to set this up. Requirements have all the libraries, everything, and that's the database file that you populate. So let me walk you through how the application is structured. This is the basically the folder. Inside the app, you have the models.py. That's this, and it defines the SQL model classes, one for taxon and one for taxon name. Each taxon stores taxon ID, parent taxon ID, and the rank. Taxon name table includes things like scientific name, synonyms, and name class. In the populate.py, that's this particular file, I read and pass the DMP file, that's dump files, and provided in the NCBI taxonomy dump format. And those files are in the data folder. I'll show them to you. The script cleans the input lines, populates the SQLite database using SQL model. The API routes to the api.py, it's this particular file. And I've exposed two endpoints, /search. I'll show them to you in this file. So, sorry. Oh my God. Okay. Yeah. So, uh, yeah, /search and // taxa. That's this. So /search performs a paginated search based on a keyword, sorry, and match mode contains starts with, contains, and ends with. /taxa, that's the second one, that it retrieves full details of a taxon by its ID, including its parents, children, and name information. So other than this, the front end is located in the front end folder, and that has just one Python file that has the entire front end script, and it's entirely dash based, all dash modules, everything related to dash, and this means the whole application is in Python, no JavaScript or HTML needed. That's one advantage that you have. So everything is in Python. So I'll give you a live demo of basically how it works. So you open up you on one terminal, you run the front end script. On the other, you use this particular command and you run the backend where everything, all the processes happen here, and this front end just shows you what you need to see. So once this you click on this link, it opens up the web app. So this is the the format that I've chosen how to show. A very very simple format. You enter here, you enter the keyword here, you choose what you want, and you click search. So this is the landing page. It's fairly visible. I can enter any keyword here. Let's say, for example, I enter Homo for Homo sapiens, and I choose contains. Let's start with contains. So this all of them, all the search results show up, and though there are only 5 of them, if I click there, no matches found, but yeah. And then if I were to say starts with, again, all of them, because all of them are starting with Homo, ends with. So there's only one, and it's there. Another example will be man. Man has, sorry, contains man. So see, as you can see, there are 22 results. So there'll be more pages and more results, and that's how it works. Let's say, for example, if I were to not have something, and I search a random result, like blah blah blah, and I say search, it will say no matches found. So you're searching something wrong. So again, coming back to a proper result, when I click on the search button, this comes up, and then you click on an ID, it opens up a further detailed place where you have the parent taxon, and then this particular one doesn't have any children taxa, but it's all the synonyms, all the names related to this particular taxon. So this is how the results are paginated. I can use next and previous button. I can use this back to search result button. Oh, matter of fact, if I go in here and you click home, it straight up goes back to the same line page that you had, landing page. So you can put in more entries that you want and then test it out. So a little more detailed search. And let's say I search man contains. Oh, let's use something else. Starts with mandrilus, and see, all the details are there. There's child taxons. There's all the synonym names, the parent taxon, the rank, taxon detail, and here I can see like it holds a lot of information over here. And at the bottom you can see there's back to search results, which will take you back to the exact thing that you searched on. But this particular URL here, if you keep clicking on this, logically it should go back to root, because everything has one root, all of us, and see, that's how it works. This the entire super kingdom that holds all the other kingdoms, sub kingdoms, and then further down the taxonomy. So logically it should go back to eukaryotes, and that's what happens here. And if you click home, it again reloads the same page. So this is how I made it, and then the entire script runs, and this is how the web application works. You can actually search up anything. If you want to search up gorilla, you can have all the gorilla results, and it shows 10 per page. So next, and then 20, and then next one. Click on any one of them, it actually has all the information that you need. So we can just move this aside. Okay. So the challenges I faced while making this was firstly parsing the dump DMF files. That took me quite some time to get my code running on that. And these files use a custom pipe delimited format with spaces and extra trailing characters. So I had to clean it and format it each line manually. And another, I should have studied that. So these are the the data file. This is where the input data is accessed from, and basically, notepad, was it notepad? Yeah, notepad. So that's how a particular node file. Oh shit. Previous project. So that's how node file looks, and that's how a dump file looks. Yeah, that's how a dump file looks. So parsing that data was one of the challenges that I faced. Another tricky part was modeling the self-referencing parent-child relationship in SQL model. I think this was one of the key aspects that I'm pretty sure the professor wanted us to learn, of how exactly self-referencing works. And it took me quite some time to understand, but I was able to get there. And I solved this by creating a relationship that points back to the same table. So relating each of them, and then if you were to click on that, it gets you back to where it come from. And finally, well, from a front end, this is all back end. So from a front end perspective, aligning multiple tables using dash in dash was difficult. It's fairly irritating to not get it aligned properly, and making sure that the children table, the names table, had matching column widths, and I resolved this by properly seeing the width and the layouts that I want. Finally, ensuring the search bar, the drop down, and the button were evenly spaced out. Looks it's pleasing to the eyes. It shouldn't be unsymmetrical, and you shouldn't be wanting to look at it and be like, I don't want to search something. So I want to talk about routing and navigation a little. One thing I wanted to emphasize was was user experience. When you click the taxon detail page, this particular page, uh, you can go back to the search result. That's one this. But if you want to search something entirely different, you can actually click on home, and it gives you a completely a range of options. So here you go back here if you want to, and then you can search something entirely different. Click home and it refreshes the entire thing. You can search it again. So that helps the user to choose whatever he wants to, and the URL stores the search keyword. So it remembers that even if you want to search man, and it stores that you search man, and then once you click on this, it actually goes back to what you searched. That one I want to make that simple for the user. And a summary. This project brought together a lot of core concepts of this course: file parsing, database modeling, API development, front end. Though it was a short lecture, but the professor gave a very in-depth analysis in a very short time, and I was able to actually understand a lot of things when I went through it by myself. And I actually had the opportunity to go back to the lecture and understand it through the professor's view as well, and it's fully reproducible using only Python. That's one of the main thing that I didn't have to use any other coding language, and it was a good experience. And it's based on real world bioinformatics data, so you actually might find this on NCBI, their website. So it was a good project. I was able to learn a lot, and it was good. Thank you for watching my demo. I mean, though we have to submit it, this entire learning process was what it teaches me how flexible Python is and how easily you can use it to do what you want to do, and especially in my field of bioinformatics. So, thank you for your time. Thank you for watching the demo.